Hello, my amazing students. This is Mrs. A, and I love math. And today we're here with lesson 18 in our Saxon Course 3 book, and we're talking about lines and angles. So this lesson is going to have lots of definitions that you're going to want to probably get out of your book. I'm going to go over them, but you all have a book, and if I were you, I would maybe write some of these down on flashcards so that you can memorize them better. Okay, so let's start off with a line. A line is a straight path that extends in both directions to positive and negative infinity. So I've drawn a picture of a line, but actually a line is something that has no thickness. So you would not be able to see it. When you get a little bit older, they're going to tell you that a line is a set of points. And we draw our points real nice and big like that, but really, points they take up no space. Mathematical points take up no space. We just draw them so that we can see them. All right, so the important thing about this line is how we're going to name this line. When we have a line that goes through points, we can use those points to name the line. So first of all, the notice for a line, or the notation for a line, is a little line with an arrow on each end to show that it goes on and on forever. And then we name 2 points that the line goes through. So we could name A, B, okay, right underneath the line, and that denotes a line. Or we could denote BA, because this line, BA, means it starts with B and keeps on going, but since it goes in both directions, we can switch AB or BA around to our little heart's content. Here's one that we can't switch around. This is a ray. An array is a part of a line that starts at one point and goes through another point and then continues on forever. Now, what we're going to learn is that there is an infinite set of points in this array. So it goes through many, many points, but there's only one point that has been named, and that is B. So we have A and B. Since it starts at A, where our notation for array is start it at the point where it starts and go through the other point and show the ray with a arrow on just one side. So we can't switch that one around. The A definitely denotes where the ray starts, okay? Now, a segment can be read either way. So a segment is just let me put it down here, a segment AB or segment BA could both denote that segment right there. A segment is a part of a line, but it has 2 endpoints and does not go to either infinity. A plane is a flat surface that extends on and on forever and ever. We're going to talk a lot about planes. Now, one thing about lines that are in planes, okay, 2 lines in the same plane will either intersect or they will be parallel. Those are the only 2 choices. Intersect means what? They're going to cross in some way, or they're going to be parallel, which means kind of like vision railroad tracks. Railroad tracks stay the same distance apart forever, okay? And so they're railroad tracks. Parallel lines are like railroad tracks. They go on and they never, ever intersect. So they're either going to intersect or they're going to never intersect, which the definition of never intersect is parallel. Now that only works for 2 lines that are in the same plane. Now perpendicular is another term that they're defining for you. And perpendicular is when we have 2 lines that intersect, which means they cross, but they cross with square angles right here. So square is 90 degrees. So they have little 90-degree angles at the crossing points. So now I want to just talk to you a little bit about a plane. If I were to pretend like this board here is a plane and it goes on and on forever and ever. Okay, so theoretically it goes on and on forever and ever. Really, it's just a little board, right? So if I have two lines that are in that plane, that means that they're in the same, just like I was laying them on the table. Okay, they're not going to get up and dance around off a table. They're going to lie flat. That's in the plane. When the line lies flat in the plane. Okay, now you can see that these two lines would either intersect at some point, like they would cross, or they would never cross. Now, I couldn't have two lines like this because they will eventually cross. Okay, they may not cross on my little plane, on my little board, but remember, the plane goes on and on forever. And if we have two lines that are not parallel, they're just a little bit off, they will eventually cross. Okay, so these are pretty big concepts that we've got to get into our heads. Okay, so lines that are in different planes that do not cross or intersect are called skew. Okay, like a wall and a ceiling that don't touch. So here, let me show you some examples of skew lines. Okay, so this marker is going in this direction, okay? And then I'm going to come along this direction and put this marker is in another plane, because just like this marker could lie on a table, that table would be the plane. But here I've got my marker up like this, so the plane is going through the marker, okay? But this marker is coming along this direction, okay? So its plane is going in a different direction. It is not in the same plane as this marker over here. We would say they would never ever intersect, because remember, this plane, this line is going this direction, okay? This line is going this direction, and they're not in the same plane. They're never going to intersect. They're skew to each other. So let's say you had a room, okay? And in this room, here's a room, and you had a wall on this side of the room, okay? So here's a wall. But then over here, you had the corner of the ceiling. Are those ever going to touch each other? Are those two lines going to ever touch each other? One's way over here. Now, if I had one over here, they would intersect, wouldn't they? Okay. But if I have one over here, like it's the line to the ceiling, and this is the floor of my room, then those two are never going to cross, because one's on one side of the room and one's on the other side of the room. They're not in the same plane, and they'll never cross. That's what it means by saying, okay, they're not in the same plane and they never cross. This one's in this plane on this wall, but this one would be on the ceiling, and they would cross. This wall would come up and intersect with the ceiling, wouldn't it? Okay, so that's what they mean by they're not in the same plane, but they intersect. Okay, so basically, actually, that one would be in the same plane, because this plane goes up and the plane, so that's a bad example of that one. Those would be in the same plane. All right, so let's go to the next concept. That is skew. All right, so now intersecting lines form angles. Okay, and angles are two rays that are joined at a point, and that point is called the vertex. And then these two rays become the sides of the angle. And this right here in the middle is the angle. Now, hopefully you've played with angles before, but if you haven't, we'll be playing with them some in here. Okay, so we measure angles with a protractor, and right now we're mostly naming these figures, but we'll be measuring them later on. Okay, so when we're naming an angle, we can call it by 3 letters, and the middle letter is always the vertex of the angle. Okay, so A, B, C, ABC. Angle looks like this. Angle ABC. If we can't be confused in any way, we can name an angle by 1 point. So here, even though I have A, B, C, I mislabeled that one. Even though I have A, B, C, the B is all I need, really, because that's the angle right there, and there's no way to confuse it. All right, we can also call angles by numbers. We could have a little 2 there, like we could have in a triangle, a 1, 2, 3 angle, and we could say angle 2. Okay, so angle 2, angle B, angle ABC. Now, the cool thing about angles is they go both ways. So instead of just ABC, we could call it angle CBA. And angle CBA and angle ABC are the same. The only rule is that the middle letter is the vertex, and it is, so they name the same angle. Okay, so what they mean by confusion, if I had, I'll get the second board out here, third board, if I had an angle going this way, all right, but you can see that I have an angle here, but I also have another angle here. And we'll learn that this down here is called a straight angle. So we really would have 3 angles in that figure, and we don't know which one we're talking about. So that's what they mean when they say if there could not be any confusion. Okay, so the last thing is degrees, and that's what we measure angles with. Degrees are little units. There are 360 degrees in a full trip around, and so there's 90, which is a fourth of 360. 36 divided by 9 is 4, right? So it's a fourth. 90 is a fourth of a full circle. Okay, so that's 90 degrees right there, and we call that a right angle, which we're going to come back and talk about that in a minute. Okay, so when we're talking about angles, we have 4 types that we usually talk about. Acute, remember when you see a cute little baby, it's tiny. Okay, acute is a tiny angle. It's less than 90 degrees. Obtuse is a big angle. Okay, big, obtuse. All right, a right angle is 90 degrees. I made that one look a little bit bigger than 90. I should have gotten a protractor to measure, but I'll show you that in a minute. Okay, right angles is 90 degrees in the center. So they're going to be perpendicular rays in that angle. And then a straight angle is one that forms a straight line. So basically this side, you see the little dot in the middle. That distance right around there is 180 degrees if I were to put the protractor right there and measure all the way across. So let's talk about straight angles for a minute. If I have 2 angles that form a straight angle, which means that's a straight line at the bottom, then we call those 2 angles, in this case it's angle A and angle B, those 2 form a linear pair. And they form a linear pair because when I add them together, I get 180 degrees, or a straight line, and angle A plus angle B is equal to 180. All right, now, in this case, I have labeled the angle with this little measure right here. That's another way that we keep the angles straight. So basically, I just erased it with my pen. But that little angle measure there is B, and that little angle measure there is A. And when I add the 2 together, I get 180 degrees. They form a straight angle. Therefore, they are linear pairs. Now, we're going to learn about a protractor. And a protractor looks like this, okay? Looks like kind of a half circle, very, very much like a half circle, okay? And it's going to help us measure our angles. So when we have an angle, so I'm trying to measure this angle right here. Okay, and I don't need to call the angle anything right now. But if I did want to write it, I would say measure of angle, we're just going to call that angle A. Measure of angle A equals, okay? So measure of angle A equals what? So we're going to get our protractor. And we're going to put our protractor right where, you see in the center, there's a little hole right here. And we're going to center that on the vertex. Now I'm looking in the mirror in the camera. That looks pretty centered to me. Now when we center it on the vertex, we have to make sure there's a little line running right through here. Okay? And I want to center that line right on the line that I see. So I'm going to make it so I don't see white, so that I know that I'm on that line. Let me look at it. I did pretty well looking in the camera. I did very well. Okay, so now once we have lined up the bottom line on the actual ray, the bottom ray, and we have the point, the vertex, right inside that little point in the center right there, then we can measure our angle by looking up here to see where our angle goes. So I'm going to try to hold this and move it real close to the camera and see if you can see what that measures. Okay, get your idea in your head. Now you can see that on the protractor there are actually two measures for each line that goes through, but you are measuring a small angle. So you're going to pick the smaller of the two numbers. If you are measuring a large angle, you would pick the larger of the two numbers. Okay, so let me see what it is. It's real close to 40 degrees. So you can see that there is a 40 and a 140 right there, but you're measuring a little angle, therefore you're going to use the 40. And that angle is 40 degrees. Okay, so we're going to do some practices. We're on your practice set already. Our practice set is not going to take us long today. Okay, so it says name each figure in problems A through C. So I put A and B here. And since this is going on in both directions, that is a line. Remember, lines we can name either direction. So we would call this line PQ or line QP. And naming it on paper is important. We make a little line with arrows to show that it is a line, and we put PQ right underneath it. Okay, or line QP right underneath it. That's all there is to it. Okay, so on number 2, we have a ray. Remember, a ray starts in one place and goes on forever through another point. The starting point is important. We always have to put that first. So we're going to put ray. Okay, so you can either put a point there and draw a ray, or you can just start the line there. But it only has an arrow on one end. And we're going to put the starting point P and then Q in the name of the ray. So that's ray P Q. Okay, so then we have to name the figure in C. And remember, when it has an endpoint on both sides, it's a segment. Okay, so this is segment PQ or segment QP. All right, so the direction doesn't matter. So PQ with a little line over it, okay, or QP with a little line over it. But notice the line has no arrows. That means it stops because there's no arrow indicating that it goes further. Okay, and then in D, we're supposed to describe the pair of lines. So as best I could, I made these lines look parallel. Parallel means like railroad tracks. They're the same distance apart all the way. And as I look at these don't look very parallel because they look like they're getting too far apart. but I don't have anything there to make them look real good. So parallel lines stay the same distance apart, just like railroad tracks would stay the same distance apart all the time, or the train would be in trouble. Okay, so parallel lines, parallel. Okay, and these two lines are intersecting, but they're more special than just intersecting. They have a little box there indicating 90 degrees. Therefore, that angle right there is a right angle, and the whole two lines are called perpendicular. So perpendicular, and I ran out of space. Perpendicular means that two lines are intersecting in 90-degree angles. And now we're already on F. Okay, so F says that we have a figure, and we're going to describe each angle as acute, obtuse, right, or straight. That's pretty easy. Okay, so first of all, they tell us to look at angle CMD. Okay, angle CMD. Now remember, that means that M, the center letter, must be the vertex. So let's find M. It's right there. Okay, so CMD. CMD. So aren't we talking about this little angle right there? And that's a little bitty angle. It's less than 90 degrees. So CMD is acute. It's a cute little angle, like a cute little baby. Okay? CMA. CMA. Okay, now CMA is this big angle. Now I'm going to erase this one because I'm done with that one for right now. CMA. We're talking about a bigger than 90-degree angle. Okay, it's larger than 90 degrees, therefore it is obtuse. Okay, so obtuse. AMB, AMB, so let's erase this one. AMB. Now, I didn't draw that, but that's in your book. That little square right there is in your book, and I forgot to draw it. Since it has a little square there, that means that's 90 degrees, which is a right angle, and that means that this one is a right angle. Okay, so then AMD. So AMD, look at that. We're going straight across. AMD, that's going to be a straight angle. And we have one more practice problem before we start our homework. Okay, so this is J. It is our last practice problem of this lesson. Okay, now it says it's a reasoning problem. If DMC, angle DMC is 45 degrees. Okay, so first we have to find angle DMC. So DMC, so right in here is 45 degrees. Okay, because they told us so. So then it says, then what is the measure of angle CMA? So C is right here, M is right here, A is right here. So CMA is this angle right here. Now, how can we figure that out? Don't we know that this is a straight line down here? Okay, so DMA here is a straight angle. And then we have 45 degrees right here. So wouldn't this one right here be 180 minus 45? 180 minus 45 degrees. I'm going to borrow and get 5, 3, 1. 135 degrees. So 135 degrees. Those two angles form a linear pair, which means together they add to a straight line, or 180 degrees. So I can just take 180 degrees minus one of them has to equal the other one. And now we're ready for problem number 1. Okay, so here we are on our written practice, doing practice problem, or written practice number 1. Says Michaela estimated that there were about 9 tables in the room with about 6 people seated at each table. About how many people were seated at the table? So this is just an estimation. They tell us about how many tables and about how many people per table. In fact, yep, she estimated both of them. So all we can do is go, okay, hopefully she had a pretty good estimate, and we would say 9 times 6, because there's 6 people at each of 9 tables. So 9 times 6 is 54 people seated at the tables. Okay, so that's an estimation problem. Number 2. It says the temperature at 8 a.m. was 65 degrees Fahrenheit. By 11 a.m., the temperature had increased 17 degrees. What was the temperature at 11 a.m.? Okay, so here, 11 a.m., it was 65 degrees, and then it increases 17 degrees by the time we get to 11 a.m. What is the temperature at 11 a.m.? Okay, guys, this is not rocket science. What am I going to do? I'm going to start with 65, and I'm going to add the 17 degrees. 65 plus 17. Okay, 5 plus 7 is 12. And then 8. 82 degrees Fahrenheit is the temperature at 11 o'clock. Number 3. Of the 50 customers, 35 bought the advertised item. What fraction of the customers bought the advertised item? What percent bought the advertised item? Okay, so there's 50 customers altogether, and 35 bought. Okay, so when we put the altogether number 50 on the bottom, okay, 50 bought, and 50 altogether, 35 bought. Okay, now that is the right fraction, but it is not in its most simplified form. So we're going to divide by 5 on the numerator and the denominator. So I divide by 5, and I divide by the same thing, and I get 7/10. Okay, so 7/10 is the simplified fraction. How do I turn a fraction into a percent? Okay, so 7/10 is the same as 0.7, which is the same as, remember the decimal there, add a 0, 0.70 is 70%. Remember, if we have a point, we're going to move the decimal place 2 places to the right. Okay, there's another way that we could have done it. 70%. All right, remember, percent means I'm going to get a 100 on the bottom. Okay, well, here I've got 50 on the bottom. So what if I multiply my fraction by 2 on the top and 2 on the bottom? So times 2 times 2, and I'm going to get 70 over 100. And when I have 100 in the denominator, that's just 70%. Okay, if that's hard for you, you need to still practice going from percents to decimals, decimals to percents, percents to fractions, fractions to percents. That's a very necessary skill. Okay, number 4. How many cups are in 3 gallons? How many cups are in 3 gallons? Well, I'm going to go back over to page 37, because remember, page 37 is where we have our table of measures. So I'm going to hold this up to the screen and see if you can find something that's going to deal with cups. All right, so look at the picture here. See if you can find, we're looking for cups and gallons. We have 3 gallons. We're trying to figure out how many cups. Okay, hopefully you saw it. I'm going to look at it real quickly. And we have, let's see, cups. All right, well, I know that there are 2 cups in a pint. Okay, so I know that. It doesn't say it on here, but I know it to be true. I'm just trying to see if they don't give that to me anywhere. And I don't see it, but I know that there's 2 cups in 1 pint, right? I know that there's 2 cups in 1 pint. Okay, so I know also from the chart that there are 2 pints in 1 quart. So 2 pints equals 1 quart. Now, what do we know about quarts and gallons? 4 quarts. 4 quarts equals 1 gallon. Okay, so now, how am I going to use this information to come up with my answer? So for this, I'm going to get my really big board because I want to be able to go all the way across the board, okay? So that you see one connected. We're going to start with 3 gallons. Okay, now I'm going to multiply. I'm going to use unit multipliers or conversion factors to get there. I know I want to get to something really tiny. I want to get to cups. So I'm going to go first to quarts. And I know there are 4 quarts per gallon. And I want the gallon to be on the bottom because I want gallon and gallon to cancel. Now, wouldn't it make sense if the next thing I had on the bottom was quarts? Because I want the quarts on the bottom and the quarts on the top to cancel. So I'm going to go from quarts to something smaller. And I have what? 1 quart is 2 pints. So 1 quart is 2 pints. Okay, so now my quarts and my quarts cancel. So now, don't I want pints to be on the bottom? And I know that 2 cups is 1 pint. So 2 cups is 1 pint. So now pints cancels pints. And I am all ready to do my multiplication because I have canceled my gallons, canceled my quarts, canceled my pints. I'm left with cups. Cups is what I wanted. Now, I already have the 3 sitting there, don't I? 3 gallons was what we started with. So now all I have to do is multiply. 3 times 4 times 2 times 2. And on the bottom, I just had 1 gallon, 1 quart, 1 pint. So there's nothing on the bottom, just 1 times 1 times 1. So now 3 times 4 is 12. Times 2 times 2 is 4. 12 times 4 is 48 cups. 48 cups, and that is correct. And that is the correct way to write that problem. Some of you are trying to get by with doing a lot less than that, but as you go up in math, it's going to get more difficult, and you need to do the steps. Follow the rules. Gallons needs gallons below so that gallons will cancel. Okay, quarts needs quarts below so that quarts will cancel. It's very easy. Okay, but y'all are fighting it. You don't like to do it that way. All right, so the next problem, I got to get back to our problem page here. I lost my place. We're on lesson 18, and we're doing number 5. Okay, and number 5 says Cleo walked 3 miles in 45 minutes. What was his average rate in minutes per mile? What about miles per hour? We're going to have to think a little bit here, aren't we? Okay, so I'm going to get my big board again because it's a bigger problem. And so we're going to start with 3 miles in 45 minutes. Now, the first thing they ask us is pretty easy. They said minutes per mile. but they gave us miles per minute. Can't we just flip it over? Can't we say this is the same thing as 3 miles on the bottom and 45 minutes on the top? So if we flip it over, then don't we already have it in the minutes per mile? So when we have minutes per mile, we just want 1 on the bottom. So I'm going to divide by 3 and 3. 45 divided by 3 is 15. And 3 divided by 3 is 1. When I have a 1 on the bottom, I don't need it there at all. So 15 minutes per mile. Okay? So every mile takes him 15 minutes to walk. Now, the second part is to write it in miles per hour. Okay? Now we started with this one. So let's think about this. Okay? Miles per hour. There's several ways that we could do this. First of all, I'm going to start with this one right here. I know that I have 3 miles in 45 minutes. I'm showing you the easiest way to do it first. So now we want hours on the bottom. We want miles per hour. We already have miles on the top. We don't need that to cancel, do we? So I'm going to leave the miles alone. I want the minutes to turn into hours. So I'm going to multiply. If minutes is on the bottom and I want to get rid of it, don't I need minutes on the top? And I'm trying to get to hours on the bottom. So I'm going to now put the numbers in. I know that 1 hour is 60 minutes. All right. So now I've got my problem set up for me. Now I could do this by multiplying 3 times 60 and then dividing by 45. That would not be the easiest way to do it. What if I went ahead and divided this by 3 and this by 3? I already know that 15 into 60 goes 4 times. So 4 is what happens when we cancel 15 and 60. And now look at our units. Miles is still on top. Minutes cancels minutes, and hours is on the bottom. So didn't I accomplish miles per hour? I did. Okay. Now, another way that you could have done that is you could have said, okay, I need an hour on the bottom, and I have basically 45 minutes is 3/4 of an hour. Okay. So if I had 3/4 of an hour, 45 minutes would be 3/4 of an hour. 3/4 of an hour. I could do that in my head. But then I need to get 1 on the bottom. So wouldn't I multiply by 4/3 on the bottom and multiply by 4/3 on the top? And 3 on the top and 3 on the bottom gives you 4 left. And that's what we had. So that would be another way that you could do it. Just change minutes into parts of an hour. I think this one is easier. I think this one is clearer to do. Okay. So, but we have to learn how to do both of those. And the very last problem that we're going to work today is, oops, we're going to do 2 more. I'm going to do 7 problems for you because we have to evaluate 12 squared. We know 12 squared is 12 times 12, which is 144. And the square root of 144 is that number that when squared gives us 144, which we just found out was 12 times 12. So the square root of 144 is 12. 12 squared is 144. And we are done with lesson number 18. Now it's time for you to go do your homework. This is Mrs. A, and may God bless your day.